Hi, students. I wanted to take some time to review with you your Go with the Flow Google Form activity that also went along with your simulation, the PHET simulation on series and parallel circuits. So you start off with filling out this form here, Go with the Flow, and asked you a couple questions about let me just read this to you. It says, you flick a light switch and there's light. Modern society has become increasingly dependent on electricity over the years, as our knowledge of electricity has led to many new inventions. Today, we hardly give a thought to how electricity and circuits can produce light, heat, sound, motion, and even magnetic effects. So I ask that you paused for a moment and imagine how your everyday life would be affected without electricity and how it would be different. And I had a lot of good responses. A lot of you said, well, the technology component, we would not have computers that we could use. We wouldn't have the internet. You wouldn't be able to play video games. It'd be really hard to cook dinner. There wouldn't be any lights in the home. You wouldn't be able to watch TV. You couldn't use your microwave. And you just all felt like it would be very different. Life would be very different without electricity. And, you know, having this winter weather that we've had recently, and if you have lost power, you know how much we do take electricity for granted and how much we do rely on electricity. And some of you may actually have an alternative form to generate electricity with a generator, and some of you may have actually had to use it this weekend. All right, so let's move on to the actual PHET simulation and look at some of the actual parts of it. The first thing you were to do was to ask you a few questions about resistance, current, and voltage. And just to review, voltage is the potential energy difference between two different places. Okay, so in this case, you're getting voltage from a battery, and this is direct current because you have the electrons moving in one direction, one from one side of the battery back to the other side. Okay, alternating current, you'd have these electrons kind of reverberating back and forth. And you would find that in most of your outlets in your homes, or all of your outlets in your homes for that matter. Okay, so voltage has to do with the energy source. And the higher the voltage, the higher potential difference between from this point here and this point here. Okay. And what flows in the circuit? Well, it's electrons that flow, and current is measured in amps. And current is the rate of flow of electrons through a conductor, in this case, a wire. And so when current flows into a thin tungsten wire inside a light bulb, the resistance of the wire causes it to heat up and glow, and that gives it radiant and thermal energy. Okay, so the resistance of these batteries here, these light bulbs are 10 ohms of resistance, and that causes it to glow. So you were to create these circuits. Step one was to create a circuit, a simple series circuit with one bulb, which is represented here. You were to measure, actually, I think I gave this one as an example. The measured amperage was 9 volts, or 9 amps. So you just brought your ammeter over and put the probe on the actual conductor wire. You would have gotten 9 amps of current. And in this case, you could see the bulbs had the highest brightness out of the 3 examples here. Then you were to add a second bulb and then a third bulb and compare what happened. So you all pretty much understood that as you added light bulbs, the current decreased. Okay, it was 0.5 amps, 4.5 amps here with 2 bulbs, and 0.3 amps with 3 bulbs. And you can see the brightness of the bulbs also reduced. So after you had completed these 2 data tables, I think the next one you had to do was 2 batteries. So you just had to add a second battery here. All right, and we're going to add a second battery down here. And you just had to compare the current again in these different scenarios and write down on your data table what you saw happen. We could probably actually use this in the lab, and I could just increase the current instead of adding a second battery, but this is fine. All right, so if you notice your current flowing through the series circuits with one light bulb was 1.8 amps. With 2, it was 0.9, and with 3, it was 0.6. So again, very similar to what happened with the first battery, except with a higher voltage, you can see you're going to have more relative current flowing through the wires. All right, and then what you were to do was disconnect one of the bulbs in series. And you could see that when one bulb went out, they all went out. And then you should have also noted that when you add more bulbs, you have less current and the bulbs become dimmer. As far as what effect does increasing voltage have on the current, you should notice the current increases as you add more voltage in a series circuit. And then if you were to unscrew a light bulb, it's very similar to disconnecting. You create an open switch and all the bulbs would go out as well. It doesn't mean that they aren't working. It's just that because electricity is not flowing through it, you're not going to see it light up. And you should have also realized that increasing current increased the brightness of the bulbs as well. So if we compare one battery versus 2 batteries, the brightness of the bulbs is going to be greater with 2 batteries. And also you should have realized that when you added bulbs in a series circuit with 2 dry cells, it did affect the amount of current, and it actually decreased the current as you added more bulbs to the battery, okay, as you see right here, with 1 battery or 2 batteries. So in conclusion, from your data and your observations concerning series circuits with 1, 2, and 3 bulbs and 1 or 2 dry cells, you should have concluded that voltage and current are in direct relationship. As one increases, the other increases. Part 2, you were to go ahead and make parallel circuits. And so I have that here as well, and I'm comparing these for you. We have 1 bulb added here, and let's go down to that data table. And measuring the current, and of course this is a simple series circuit with 1 battery, 1 light bulb. The current is 0.9 amps. Now we need to do 2 bulbs in parallel. So when you make them in parallel, you want to make sure the wires with the bulb are in parallel with the other branch. It just makes things easy, and it makes things easy to understand. And this is really what it looks like in real circuitry when you have designers make circuits. Okay, so you can see if we look at the current now, you're measuring it from here, okay? The branch, the current is at 1.8 amps, but look at each branch, not 0.9, 0.9. So it is summative, okay? So there's 1 battery, 2 batteries, and then you had to put 3 bulbs in parallel. So let's just hook those up. And let's look at the current now. We've got 2.7 amps, and in each branch we have 0.9. Okay? So again, let's cut this, compare, still 0.9, right? Here, and each branch, it's still 0.9. The total current has increased. So when you notice too is when you disconnect one of these bulbs that's in parallel, the other ones are still going to stay lit. So what effect does adding bulbs have on the current? Well, as you add more bulbs to a parallel circuit, you're adding more paths for electricity as well. And what effect does increasing voltage have on the current in a parallel circuit? Well, as you add another dry battery, like if we were to add another battery here, okay, it raises the current moving through the wires as well. What effect does disconnecting a bulb have on current in a parallel circuit? Well, let's take out a bulb here, and you can see the current now is 1.8 total, 1.8 with two voltage sources, or at 18 volts, I should say. If we add a second branch, you can see it's now 3.6. Each branch is going to have 1.8. We're going to add a third branch. That's also at 1.8. Each branch is going to have the same amount of current flowing. So as you add more branches, it increases the current total, but each branch is still going to have the same amount of amperage going through the wires and through the resistors. Okay, and then did adding bulbs to the parallel circuit with two dry cells affect the amount of current measured? Well, when you added more bulbs with two dry cells, it did the same thing as if you had one dry cell, right? Just relative current. You still have the same amount of current flowing through each of the branches, right? And if I were to add a fourth branch, you can see right now our current is 5.4. If I were going to add another branch here, you can see what's going to happen here as well. You can probably predict what will happen based on what you see so far. All right, now we've got 7.2, but look at your amps for each of your branches is still the same. Okay. So the current is not affected in the branches. It's the same, it's summative. You add them all up and you're going to get the total amount of current that's flowing back from and back to the battery. Okay. And so voltage and current are a direct relationship. As one increases, the other increases. And then some of you had mentioned when you compare and contrast the effect of adding bulbs to the amount of current measured in a series circuit with the effect of adding bulbs to a parallel circuit. Let me share with you your answers. So some of you guys said when you add a bulb to a series circuit, the other light gets dimmer and there is less current. In a series circuit, the light stays the same as, I think you meant in a parallel circuit, the light stays the same as the current. The more bulbs you have, the brighter it becomes because it is less resistance, and having more batteries makes it brighter. When taking away bulbs and batteries make it dimmer because there's more resistance. When adding bulbs to a series circuit, the current is divided evenly between all of them. In a parallel circuit, it somehow stays the exact same current the whole time. They both light up bulbs, but it really depends on what you want to use it on. This person said, I think that when using a parallel circuit, it helps the lighting continue to stay bright for a longer amount of time. I say this because the wire continues to connect to the next. I also say this because parallel circuits are used in homes, and since we use our home electricity so much, it's important to have the best electrical system. I think that when you use a parallel circuit, it differs from a series circuit because one goes to multiple ending and the other only has one destination. In a series circuit, the current decreases as you add more bulbs, whereas a parallel circuit is the opposite. It increases as you add more bulbs. Right, in parallel. Okay, there's some more answers. So this person said, when I added more bulbs to a series circuit, the current, but on the other hand, I think you meant current decrease, but on the other hand, when I added bulbs to a parallel circuit, it increased the current. I think the parallel circuit current increases because it has multiple ways for the current to go. Right. Unlike a series circuit only has one path. Okay. And then what type of circuits do you use in your home? Parallel is definitely what we use in our home. If we used a series circuit, then all the electrical outlets would be connected. And if you turn on one light, then they'd all turn on. With a parallel circuit, you're able to turn off and on multiple different electrical things. The fuse box controls many different parts of the home from one place. In a way, the entire house is part of one big circuit, but has many different parallel circuits. That's exactly right. And the reason this person knows this is because when you turn off one part of the house, it doesn't turn off everything. That would be a really good question to see if you guys can find your fuse box in your home. Most of the time, you're going to find it in the garage somewhere. And maybe an adult can show you where your fuse box is located and how many switches you have in your fuse box. And that concludes our review on Go with the Flow. Let me know if you have any questions.